Okay, so yesterday we first started off with sine law on page 260, and I want to say that that's sides. First we just did sides, right? On page 260, just solving for a missing side. So that's what we started off with on 260. Just put sides next to sine law at the top on 260. And then we went, so we solved a bunch of those. We actually solved the whole triangle. I always emphasize that you start with the pair that you have. That's what I would start with every time. And then on 263, we started to use the sine law to solve for angles. So I don't know if you want to just put... Hi there.
Hi, is Walter in class?
Walter Daniel? No.
Not in class?
No, I'm not in class.
Okay, just in case he does show up, can you take to the office?
Will do, yeah.
Thank you.
Yeah. So that's on the video now. Anyways, sine law to solve for angles. So let's just review how we did that. I would strongly encourage you to have an example of each on your study sheet. So first off, you realize that there was a pair. So immediately you should think this is sine law. We set that pair up like we did before. And we needed to find angle A first. Why? Because we had the side length across that angle. You always need to have something opposite to what you want to find. That's the key here. So we use capitals for angles, right? So that A there, if there's no letter, you assign it a letter, okay? Oftentimes there are no letters, you call it A, B, C, D, whatever you want to call it. And then we cross multiply and divide, but note that A doesn't just show up like that. That's the biggest mistake I see is students just drop that sign, right? The first step is sine A, cross multiply and divide. So you show that on the other side. Then you go equals a decimal. And notice what happens next, right? The next line from here, A is by itself, but sine shows up as sine inverse. It's like the opposite operation of sine. So it's almost like you get rid of it by taking the inverse of both sides. But this is how you show that step. And you plug in that decimal here. Preferably you want to use all decimals, even better. And that was our angle A. Now that we have angle A, we have two angles. So we can find angle C, but all you need to do is show this. 180 minus the 81 that we already know, minus 47.26, which we just found. So angle C is 51.74. And some of you got 47.25 because you used all decimals. Good. That's good. I think if we use 5 decimals up here, it should be the same for everybody. Why don't we make that call? Okay. Use 5 decimals. So we'll change that to 5. I will quickly just calculate that again so that I know what it is. Sine of 81 divided by 123.2. It's supposed to be 0.73435. So I keep everything, right? 4 decimals, and then the fifth you have to see what you're going to round it to, and it stays 5 because there's a 2 next to it. And let me just try that here. Sine inverse of 0.73435. Yeah, that gives me 47.25. Mr. Jason, you're going to change everything? Yeah, I will. You're ruining my notes. Yeah, there you go. So let's fix that so that we're always the same, and you don't have to worry about the key being off or you being off. It's all good. Okay, can I just say something here? Sometimes I will zoom out a little bit so that you can see. Sometimes the question could go straight to solve the size of angle C, straight to C. And you're like, okay, I have my pair and C is here. I don't have the side here. I can't do it. Well, you got to do it in 2 steps. You got to solve for angle A first and then find angle C, right? So sometimes it's not going to guide you. You're just going to have to know what to do when. So just start solving for things you do know, and sometimes you'll be surprised you get to the final answer. Let's go to page 264, and I would like you. This is mixing it up, by the way. It's mixing up side and or angle. Okay. So I want you to practice these 3 right now with what you know. So A is only asking for this angle here. B is only asking for the angle down here. And C is asking for a side length and an angle. So I want you to try all 3, see what you get before we move on. Okay? Got it right, that's fine. If not, just pay attention. So I'm going to walk you through this, how you should be thinking, right? Imagine we're like 2 days, 3 days past this part. So you're like, wait a minute, what would I use here? Oh, I have a pair, right? I like to circle it. I don't know what it is. I'm like, yeah, definitely sine law. So I'm going to start with that. So sine of 81 over 15.3 centimeters. Okay. And on the other side, what would I find next? There's only one reasonable option here. You have this side, therefore, it makes sense to find angle n first. Okay. So I will say sine of n is 6.5 centimeters. Question, will n be bigger or smaller than 81? Look at the side length. It's shorter than this one, right? So n is supposed to be smaller than 81. So let's figure that out. Let's show our work here. Cross multiply and divide. Good old cross multiplying and dividing, right? Never goes away. That's the one skill, right? I'm going to add a third line like this and figure out what this is. And I'm going to do that with you. So it has to be 0 point something. If it's not, you are going to get an error. And which means that you set it up wrong. 41961, right? If you round it to 5 decimals. And then this is a step that must follow. You can't just say n is equal to something. You have to show me that you're using the inverse. I'm going to use all decimals here. So I'm going to go shift sign, try it. If you hit shift sign equals, you get that. Yeah. So you skip this step. Did you put it right next to here? Or did you just go from here to here? Yeah, I'm okay with that. I'm okay with that. As long as this inverse shows up and this, right, I can tell that, yeah, I'm okay with that. And then 2481 if you round it. And that's also using 5. Did you get the same if you do 5 decimals? I should check. 41961. Yeah, I still get 2481. We solved that angle, check. But we're still left with side M. You need angle M. You can't do it without. So let's find that right away. Angle M, I want you to show this step somewhere on this diagram. I don't care where, just make sure it shows up. Because you get a mark for that, okay? You get a mark for getting this right. And so you get 7419. Let's insert that. I'm going to use a different color just to make sure this was not provided at first. But now we have the angle across the side we're interested in. Watch this. I'm starting with a pair that I know. Even though I have a second pair now, right? I just found the 2481 here. You could use that, but I always go back to the original because then you're less likely to make a mistake. So this is sine of 7419 over side M. No inverse when you're trying to find a side. Remember that. This is just M, right? No sine of M or anything like that. Sine of 7419 divided by sine of 81. If you figure that out, you get 14.90. And I'm so used to giving 2 decimals, that's why when it's centimeters or anything like that, 14.9 is okay. But I'm so used to, I just want you to get used to that. Just give me 2 decimals. You can't go wrong. There's your side length. Okay. Just a quick check. The largest angle is 81, right? Out of all the angles that are present. And so the longest side is 15.3 centimeters, which makes sense, right? Out of the 3 sides, this is the longest side. So that adds up. Okay. Because there will be a point where it will ask you, find the largest angle. Where would it be? Across the longest side, okay? Okay, so how much time do we have? We still have time. I'm going to ask you to do this. I'm going to leave the AC for tomorrow. In the meantime, we're going to do one word problem, and then I'm going to assign you a little bit of work from the booklet, and I will hand those tests back to you while you're working, okay? Let's go to page 265. Make sure you have a highlighter if you can, that would be great. And put your thinking caps on because now it's starting to, we're going to introduce triangles that you don't see. Okay? All right. Good. Miguel is an arborist and needs to calculate the height of the tree that he will be removing from a construction site. The tree is leaning at an angle of 85 degrees with the ground. Miguel stands 30 meters from the base of the tree, calculates the angle of elevation to the top of the tree to be 32 degrees. Calculate the length of the tree. Okay. You're like, whoa, there's a lot of stuff going on. If I didn't give you a diagram, let's pretend like we don't have a diagram. If you were to put the 32 degrees in there, where would you put it on this triangle? It should make sense that it goes there, because angle of elevation is between the horizontal and the line of sight looking up, right? So 32 being there makes sense. The tree is leaning 85 degrees with the ground. So if this is the tree and this is the ground, right, it makes an 85 degree. So it's not a perfectly straight, right? It doesn't grow, it's not straight. It's leaning a little bit. So we know that 85 is right there. We know that we're standing. Miguel is right here, right? Sometimes it's very beneficial to label that angle, right, with the first letter of the name. This is the tree right here, 30 meters away from it. So we're gonna figure out M, okay? This is the length of the tree, right? If this falls down, that's how much will be occupied on the ground. So let's figure that out. How would we do this? Do we have a pair? But not at first sight, right? At first it's like, whoa, is this maybe cosine law? No, you have two angles, okay? I will call this a hidden pair. This is that couple that hasn't announced it yet, right? You're not even holding hands in the hallway, right? It's hidden. We don't do that anymore, Mr. X. Angle T is 180 minus 32 minus 85, right? You figure that out, and you get 63 degrees. That's very important to us. I'm going to use a different marker or a pen and write that 63 in there to clearly indicate that it wasn't there at the beginning. And now you have a pair. So when you have two angles, find the third angle to get that pair. Okay. So now we can start with sine of 63 over 30 meters is equal to, which angle am I going to use? 85 or 32? You want 32, right? Because 32 is across the side you're interested in. Does that make sense? It will happen quite often. So sine of 32 over m. That's sine law in a nutshell. You have to have opposite pairs, right? So this should be pretty easy. No, what am I doing here? Sorry. M is equal to 30 times sine of 32 over sine of 63. And if you plug that in, you get 17.84 meters. So M and M, that's kind of tricky, a bad letter to use, but because capital M is here, lowercase m is over there. But if you want to call it something else, you could call it lowercase l. That's fine, okay? So that's the length of the tree. Not the height, the length. Okay? Now it's the trickier part. B is saying calculate the height of the tree. Right? The height of the tree is always measured at a 90 from the ground. Okay? So, for example, if I were to lean over like this, right, the height would be measured straight to the ground, not along myself, right? So in this case, we need to cut out a little triangle right here, okay? So let's do that. Let's draw that triangle, but we're going to make it a bit more exaggerated, right? And so this here would be the height. It makes a 90. So that's the height. This is 17.84. What else do we know? We know that this angle here, this angle on this corner is 32 degrees. This angle over here is what? 85, right? That 85 stays there. And the 30 is from end to end, right? 30 is from end to end. You can't say that 30 is just this sliver or this sliver. Okay? How many triangles do you see within that big triangle? 2, right? Only one of them is good for you to use. Should I use this triangle or this one? Well, let's look. This triangle here, you know, 1, 2, right? 2 angles and a side. So I'm gonna figure out this. That's my pair here. So cut it out. Let's cut it out here. 17.84, 85. And the 30 does not come in here, guys. The 30, you cannot put it here because we cut a chunk off, right? Do you have a pair here? It doesn't look like it, but is this a pair? This represents 90 degrees. So I'm going to say that I want sine of 90 degrees over 17.84. And on the other side, I'm going to go sine of 85 degrees over, let's call this h here. That'd be the height of the tree. Like that. So you cross multiply and you divide. So right triangles are no problem for sine law. You don't have to fear it. I think the most common mistake, I just want to show you something that you need to know. I'm going to go 17.84 times sine of 85. I get that. And then I'm going to divide it by sine of 90. Watch my screen. Did it change at all? No. I will tell you why. Let me just write this down first. Sine of 90, plug in sine of 90, and that is equal to 1, right? So if you just remember that, you don't need to divide by sine of 90, but I just like to have it there, you know, because technically that is the process that you're going through. So this is the height of the tree, which is slightly less than the actual length of the tree due to it being slanted, okay? The other side of this triangle would not have had a lot of information, right? You had no side length whatsoever. That's why we use this one. Okay. Similar skills that you just saw here will be applied on the next question. So go over, actually I'm going to skip, go to 267. Kat and Steve. I want you to try question 6, which is on page 267, and question 7, which is on the next page. I want you to try 6 and 7, and I'll hand those tests back as you're working through it. (267). Make sure you follow along and you highlight and you underline and you make those little notes that sometimes I mention things that will make your life easier. Just because, listen carefully, just because there is a line cutting it doesn't mean that you should be using either one of these smaller triangles. Always keep in mind that there's the big triangle, right? And work with it first if you can, okay? So the question is asking how far is Kat from the Pika, right? So they're asking, let's call this X here, right? So we're asking for the distance from here to here. Let's look at the big picture here. Is there a pair anywhere in sight? And you're like, this angle doesn't have a side. This angle does not have a side. This side, does it have an angle? And the answer is yes, because you have two. So we can call this angle P, right? And find a pair, right? Find angle P, and that would be 180 minus 17, this one here, minus the 36 that's over here. And so angle P ends up being 127. Don't let that scare you, right? You would get a mark for that, by the way. So grab a, right? I'm just going to make a note that this is 127 from end to end. Okay, the whole thing is 127. So now we have our proverbial pair, right? So sine of 127 over 20 meters. Notice that the 20 meters is implying that it is from end to end. If you didn't get that, just read the question. It says that they are 20 meters apart, right? Steve and Kat are 20 meters apart. So don't be thinking the 20 meters is just for the one side here. And then we're going to go sine of what? Which one of these two angles are we going to use to figure this side? 36, right? And so that is x right there. It could have been called lowercase s, right? Because Steve is here, but it doesn't matter to me. So it's 20 times sine of 36 divided by sine of 127. So this is what I mean by it's going to get trickier, okay? This is what I mean by that. So you cross multiply and divide, and you get 14.72 meters. Okay. Next question is saying, how far is Steve from Pika, right? Steve, Pika. Call it something else. Call it Y. Okay. And then we start with the same pair that I've already identified. Remember, soon you will have a second option. So if there is no pair to be had, then you need to figure it out this way, using cosine law, I guess. So now, because you're trying to find y, you're going to have to use angle 17, right? So sine of 17 over y. They're opposite each other. Cross multiply and divide. So this gives you 7.32 meters. And we kind of expected it to be the shortest side because 17 is the angle across from it. 17 degrees is the smallest angle. So Steve is closer by, Steve is closer by 7 meters almost, right? And then some. How wide is the creek? This is the tricky one. This would be a 2-mark question. Okay, so the width of the creek, right, is from end to end here. So it's inside the triangle, right? This line is inside the triangle, so you're gonna have to cut it. You decide which one you want to find because both triangles have the same amount of information available. So which one do you want to use, the left or the right? Left? To the left? So I'm going to use this one here. Doesn't matter. You should both get the same answer. Regardless of which one you pick, that width doesn't change. So we have a 90 here. This is the width of the creek. This is what used to be called X. We can actually replace that with 14.72 meters. And this angle here is 17, which I'm particularly interested in because it's across the side I'm trying to find. Hold it, Mr. Dirksen. So 17 is across W. And then you told me up here that 17 is across Y. What's going on here? Right? But now I cut this out. And because I cut it out, right, 17 is across W. And it used to be, what used to be across X for us? Across X, we would consider the 36, right? Now it's this 90 here. And by the way, if there's a 90 on this side, there's a 90 on the other side, just so you know. It's right. So it's a little different here. So this is my pair, sine of 90 over 14.72. Make sure you write this down because, right, this is where you need to make sure you are careful when you cut that you put the correct information in, right? So W is here. So we cross multiply and divide. What's sine of 90 again? Were you paying attention? Sine of 90 is 1. So it really isn't relevant in your calculation, but I would still want you to keep it there. So if you cross multiply and divide, you get 4.30 meters. And I will say this, you cannot use Pythagorean theorem here because you don't have enough information, right? You only have the one side here. You don't have this. This is not 20. This is not 20, okay? Because you cut it. 20 is from end to end, but you cut out the one triangle. Anybody use the right side? If you use the right side, you should get 4.30 as well. Exactly, okay? So it doesn't matter which side you were to use. Sometimes it doesn't matter. Sometimes it does matter because you don't have enough info. Okay. What I will say is try for homework. Try the question on 266 and 268. Homework, Mr. Dirksen? Yeah. If you're not sure, page 266 and 268.